Hi guys, so let's have a look at the second question of paper 52 of June 2016. Now this basically talks about evaluation of the data. Now the question talks about how to find a molecular mass of a particular compound, and the experiment gives all the instructions of what the procedure was done. Now if you notice carefully, there is a volatile liquid here in this syringe, which is going to be then injected into this bigger syringe. Now, before it is injected, the question talks about there is some gas, some air, which is already being pulled in, about 5 cm cube of air is already pulled in. And then once the volatile liquid is injected into the syringe, it evaporates into gas. And therefore, there's obviously going to be an increase in volume. And then it gives you a formula which could be used to figure out the molecular mass of the unknown gas. So they have given all the instructions, procedure instructions, and the formula which could be used. Now the question goes ahead and talks about that the whole procedure, as I was mentioning, you have to push in a certain amount of volatile liquid, and as it changes into a gaseous form, it's going to add it to the volume of the air which is already inside the bigger syringe. Okay. Now, when we go towards our next page, one of the first things that you have to do is to collect the data, number one. Now, the question does talk about you collecting the amount of the gas volatile liquid which converts into vapor form, and also the how much mass of the liquid has to be was used. Now, to find the mass of the liquid, it's always recommended you always give these kind of column headings. Okay, and these column headings makes it easier for you and for the teacher to understand what should be done to get that data. To find the mass of the liquid, I hope it's very clear. If you do A minus B, that's the mass of the liquid and the syringe before the injection. That's after the injection. So the difference between the two would be the amount of the liquid that you have used, and the amount of air would be the difference between, that's D minus C, as we say. After the sample is introduced, obviously the volume is going to be higher, so we do a D minus C to get that. Now interestingly, if you look at the mark allotted, it's only 2, which means you are not expected to make any mistakes in these calculations. For every wrong answer, there is possibility of a -1 mark. So once we get out of that situation, we have to make a graph. Now remember, ideally a graph should be made in about 15 minutes. That's why I said I recommend 45 minutes for this question. But it's only 2 mark. Once again, the plotting of the graph has to be done very accurately, and there is heavy penalty if the points are not correctly plotted. I have just used a rough sketch here just to give an idea of how the graph is going to look like. Okay, so when you plot all the graphs, you will get a line which is something like this. Okay, this is just to give you a little bit of idea there. And you will make your line of best fit. Now, very important for you to pick up this particular skill. Now, if this is your line of best fit, imagine if this is a point which is not falling on your line of best fit. I'm talking about this point here. So these are called anomalous point. Now, one of the easiest thing for you to understand is on y-axis, we have the volume of the vapor. Now, as you notice, this point is below the line of best fit, which means you expected this point to go a little higher, isn't it? That means you have less than expected volume of the gas. If this point was somewhere here above the line of best fit, that means you actually crossed. Maybe this point should have, that means, it should have been less than what it should be. So what you got was much higher than what it should have been. So if you get a point above the line of best fit, that means you got more volume than expected. And if you get a point below the line of best fit, which means you have less than expected volume. Now the reason, then you may have to explain why could the volume be less than expected. Now that obviously, because remember, you're dealing with a volatile gas. That means when you transfer the volatile liquid, from the small syringe to the big syringe, there's a possibility of some tiny amount of liquid to escape. This usually happens when you expose the syringe and when you're trying to insert the syringe into the big one here. Let me just show you what I'm talking. So what I'm saying is, when you insert the hypodermic syringe here, for a moment the syringe tip is exposed. That means there might be a tiny amount of liquid drop of that highly volatile liquid there, and that liquid will evaporate and therefore cause an error in the total volume of gas that you would record here. That's the problem. So that's why you are getting less than expected volume of the vapor, because some liquid might have escaped as vapor. And then once we get the graph all done, normally you will get questions as to explain how that anomalous point happened. Now, remember, I just spoke about this particular point. I hope this is very clear. It's the reason why you're getting less than expected volume of the vapor, which means some of the liquid has escaped. And then how do you reduce that possibility of that error? The easiest thing for you to do, especially when you're dealing with a highly volatile liquid, is to reduce the temperature in which it is there. The reason is, if your temperature is low, the amount of evaporation that will happen will be highly reduced. Okay, so that's one way to control the possibility of some of the volatile liquid to convert into gas. And other, of course, is to completely close the syringe with a cap. So that also prevents the loss of liquid as vapor. So I hope that question is okay. And now, of course, how to get the gradient of your graph, which I'm sure mathematically every one of you know how to do it. You don't have to very specifically take the numbers which I highlighted. You could just work with any two good points. Ideally, please be careful that the points that you select must be the points which are already on the graph. That's always the safest thing to do. Okay, some of the students take the entire line of best fit and then they take it from there. So you know how to find the gradient. Whatever you do, your answer would be somewhere close to 340. It could be a plus minus 5, could be a plus minus 10. Usually there is no recommended answers in the marking scheme, as long as so the examiner will check your working, and if they arrive at the same answer as yours based on your working, you will get all the marks there. So once we finish from here, now this is where some of you might require some help. Now the question says go ahead and find the MR. Now they already gave you the formula, if you notice. They already gave you this formula. So they are asking you to figure out the MR here. So you have to make MR the subject. So you rearrange that, and I hope you understand how this one came. You just make MR the subject. Now, what I have done here is you have to use one mathematical concept here. Whenever you find gradient, you understand that that's, volume is on the y-axis, the m was on the x-axis, if you look at your graph. So this gradient, what you get is actually v by m, right? That's the understanding there. So that's why what happened here is when I rearrange my expression, okay, so I rearranged, this is m and that's v. I rearranged it divided by v by m. Remember, when I multiply m by v, I can make it divide v by m, and v by m happens to be the gradient, which is the answer of the previous question. Okay, so v by m is the answer of the D part 1. So that's why this whole thing got divided by the answer of the D part 1. And that's how we get this number. So remember, it's a bit of rearrangement which has happened there. And that's basically how we got this answer there. Now, mass spectroscopy as of 2022 has been pushed down to AS level. Well, anyway, I'll quickly go through it. If there is a hydrocarbon which contains so much of carbon, you understand that the remaining would be obviously the hydrogen there. For the first part of this question is, how do we figure out the molecular formula of Y? Now, you might remember from your AS level discussion something about the molecular ion peak. That is something called as M plus peak. Now, M plus peak represents the molecular mass of the compound, and it's always the peak on the furthest right on your x-axis. So notice here there is a peak at 83, and there's a peak at 80. There's a peak at 84, and I think it's mentioned here as 84. Let me just confirm. So the peak at 84 represents the molecular mass of that compound, right? So once I know the molecular mass of that compound, okay, first of all, I hope everyone understands how I got the hydrogen percentage. Just subtracted 100 minus the carbon percentage, so I got my hydrogen. Once we have all the percentage, we know how to find the empirical formula. We just simplify the ratio. And once you get the empirical formula, once now the MR, this MR is from these from the spectroscope. Okay, so this MR information came from this data what they gave us. So we have a peak at 84 on the extreme right. So this peak represents the molecular mass. So instead of writing the molecular mass as 84, they gave you a mass spectral data, and they wanted you to figure out that the molecular mass is 84 from that data. So that's the only reason why they gave you that picture. And then once you have the MR, you know how to figure out the molecular formula then. We have a working formula, molecular formula equals to empirical formula times X. X is the MR divided by empirical formula mass. MR comes from the mass spectroscope data, divided by empirical formula mass. Empirical formula mass comes from CH2. So if you look at the CH2 there, so that's 12 plus 2. That's how the empirical formula mass comes in. And once you get the value of X, remember molecular formula equals to empirical formula times X. So that's why the molecular formula became C6H12. So that's about this question. I hope everything is fine for you. Let me know if you have any more doubts on this. Okay. Thank you very much.